Hello, you beautiful people. I'd just like to say before I start this video quickly, I've launched a Patreon where you can come and donate any amount you want if you would like to support the channel and help in the expansion of Intuitive. That's where your money will be going to, is just helping me free up some more time so I can do more of these videos. I'd like to stream in the future, and I'd like to do this sort of analysis for all of these different papers, the mechanics, the pure, the stats, even physics. So, you know, whatever paper you're taking, you have a great platform to doing really well in your exams. So yeah, head on over and donate if you want to help out and support the channel, but let's get into this video. Hello, and today we will be doing the 2020 new SPEC Probability and Statistics 1 paper. And let's not muck about here, let's get straight in with the first question, which is as follows. The following back-to-back stem and leaf diagram shows the annual salaries of 39 females and 39 males. And you have the key here, which tells you that how to interpret this back-to-back stem and leaf diagram. So we have this means 2-20-3 means 20,200 for the female on that side, and 20,300 for the male. So it wants you to find the median and the quartiles, which means the lower quartile and upper quartile, for the female salaries. Well, the median is the middle value. So we have 39 males here. So what will the middle value be? Well, if you think about it, let's say if we had 3 people, 1, 2, and 3. Well, the middle value is 2. And a way to find the middle value would be just we add, so our number of trials or people or whatever here is, 3, where here is 39. We just go 3 plus 1 over 2, because that gives us this middle value. So that's going to be 4 over 2, which is 2. So it gives us the middle value here, so 1, 2. But you should know that. So the middle value here for this one will be 39 plus 1 over 2. So it's like the 20th value. So if we look 20 in for females, we can go, well, that's 4, and then 9 is 13, so then we have 14, 15, 16, 17, 18, 19, 20. So this is the 20th value. So the median, we could say for females, is 22,700. So it's 22,700. And now if we want the upper and lower quartiles, well, that's sort of saying the median of the lower half, so the middle point of the lower half and the middle point of the upper half. So that will be the 10th value in here and in here. So it'll be the 10th and the 30th value. And the way I know that is because I know that this middle value, let's say, so this middle value, which is here, you have 19 values on this side and 19 values on that side. We count, 19 in, this is the 19th, and then that's the 20th. And then if you count 19 in this way, you get, that's the 19th, that's the 20th. So then you want the middle values of these two to give you the lower quartile and the upper quartile. Well, the middle value of this is just like we did before. This will be 10. It'll be 19 plus 1 over 2, which is 10. And I'm probably overkilling it here, but so it'll be the 10th value and the 30th value. That's the bottom 25% and the top 25%. So let's just count 10 in here. We've got 4, 5, 6, 7, 8, 9, 10. So this is so we could say the lower quartile for females is this value, which is 21,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 21,700 for that one. And the upper quartile for females is going to be the 30th value, or 10 values in this way. So we've got 2, 6, 7, 8, 9, 10. So it's this one. So it's 24,000. So that's that done. So it says now that you're given, well, the medium of males is 24,000. And the lower quartile for males is 22,600, and the upper quartile is 25,300. It wants us to draw some box and whisker plots. Well, we can see that our range, so the minimum to the maximum of all of these goes from, the lowest is like 20,000 and the highest is 26,600. So if we did some salaries in thousands here, we could start at 20,000 and we can move up. You know, this is 10 points, so we can see each one's going to be 100, which is a good pick for this plot. So you have 22, 23, 24, 25, 26, and 27. So that will encapsulate all of the values for men and women. So let's do this. Let's first do for females. So our lowest value for females here is 20,000. So we can draw the end of the box and whisker plot. Let's put it here. And then the lower quartile for females is 21,700. So we go 21,700, which is 3 in from here. So we got 1, 2, 3. Oh, which is here. Apology if my drawing's not very good, but you get the idea. So, and then the upper quartile is at 24,000. So let's go to 24,000, which is here. So that's your box. And then the medium, well, that is 22,700. So let's look at where that is. So that's 3 in from here. 1, 2, 3. So that's the medium. And then let's do the highest value, which for females is 26,500. So 26,500, which is here. Okay, so this is for females. And then we can do for males here. So for males, the lowest value is 20,300. So let's do it like here. 20,300. And then the lower quartile is 22,600. 22,600, which is here. No, which is 1 in. I mean, I think you guys are getting the idea here. You know, I guess I can do the whole thing. And then we do the upper quartile, which is 25,300. 300 here. And then the medium is 24,000. 24,000, which is here. And then the highest value, which is 26,600. Which is there. And that's that one done. Okay, so question 2. We have a summary of the speeds x in kilometers per hour of 22 cars passing a certain point, and we are given this information, and we want to find the variance of those speeds and also find this value here. Well, we know from our formula sheet that the standard deviation, or the variance, is equal to this. So the variance of x equals the sum of x squared over n minus the mean squared. Well, we can figure all this stuff out, and we know also that the mean equals the sum of x, the mean of x over n. So if we wanted the variance of x, we could find the variance of x minus 50. because we know that the variance of x minus 50 is going to be the same as the variance of x. Because if you think about it, if you're just shifting all of the speeds, all of these points, over by 50, well, you're not changing the variance, you're not changing the spread at all. So, you know, it's the same. So this is the variance of x equals the variance of x minus 50. You're not changing anything about the spread. So you can say that this equals the sum of x minus 50 squared over n, which is 22, minus your mean, which is, well, the sum of x minus 50 over 22 squared. And then you can substitute these points in so we can find the variance. So we get 671.0 over 22 minus 81.4 over 22 squared. And then if you put that in your calculator, you'll get a value for the variance of x minus 50, which is the same as the variance of x. So we put this in our calculator. Is 16.81. So the answer is 16.81. Cool, so we found the variance of x, and now it wants us to find the sum of these x squareds. Well, we know from here that the variance of x equals this, so we can say that 16.81 equals the sum of x squared over, well, in this case n is 22, minus the variance squared, the mean of x squared. So if we were to find the mean of x, we could then find this value here. And the thing about the mean of x, we can say that the mean of this value here equals, so think about it, equals, let's just say, it will equal the mean of x minus 50. Because again, we're just shifting all the points over by 50. So if we shift all of the points over by 50, we're also just shifting the mean over by 50. And we can calculate this. This is the sum of x minus 50. We did it above here. Over 22, which equals 81.2, 81.4 over 22, which equals 81.4 divided by 22. 81.4 divided by 22 is 3.7. So this is equal to 3.7 equals the mean minus 50. The mean of x minus 50. So if we take that over, we get a value for the mean, which is 53.7. So now we can substitute this in and then find this value here. So we can say that sum of x squared over 22 equals 16.81 plus this squared. So therefore, when we plug all this into our calculator, we get 53.7 squared plus 16.81 times 22 is 63,811. Cool. Let's continue. Question 3. We have a book club that sends 6 paperback and 2 hard books to Mrs. Hunt. She chooses 4 of these books at random to take with her on holiday. The random variable x is the number of paper books she chooses. Okay, well that's pretty important. Show the probability that she chooses exactly 2 paper books is 3/14. Okay, well, so we have, so she has, I like to write out, so she has 1, 2, 3, 4, 5, 6 paperback and 2 hardback. So we want to find out the probability that she chooses exactly 2. Well, the way that would happen is if she picked 2 paperbacks and 2 hardbacks. So, you know, the probability that she picked 2 paperbacks and 2 hardbacks would be, well, the probability of picking a paperback would be there's 6 paperbacks and 8 books, so it would be 6 over 8. When she picks that, she's then removed the book. So now there's only 5 paperbacks and 2 hardbacks. So when she picks the second paperback, that'll be 5 over 7. And then she's removed another book. And then if she wants the third one to be a hardback, well, this is 2. This is 2 out of the remaining 6. And then finally times, well, there's only 1 hardback left over the remaining 5. So that's the probability of picking the first one as a paperback, second one as a paperback, and third and fourth one as hardbacks. So that's the probability of that one situation. But the thing is there's many ways that she could do this to pick 2 paperbacks and 2 hardbacks. You know, she could pick it like a hardback, paperback, which would be another arrangement of which, you know, for this to occur, this would have a probability of, you know, let's work this out. So it'd be 6/8 times, let's do, this is 1/28. So the probability of this exact picking order to occur is 1/28. But she can pick this in many different ways. You know, the probability of her picking it like this would also be 1/28. So we need to figure out, well, how many ways can she pick it like this? And if you think about it, that's just simply saying how many ways can she arrange these. And that would be, well, how many ways can she arrange 4 things? Well, that's 4 factorial. But you have to divide by, because if we switch these two, it doesn't change anything, right? So we have to divide by 2 factorial and another 2 factorial for these switches. Because if we switch the h with the h, we get the same thing. They look identical. So we have to divide by 2 factorial because there's 2 p's, and 2 factorial because there's 2 h's. Ooh. So the total probability, so the probability when x equals 2, which is the exact number, will equal to 1/28 for that one arrangement times all of the ways that she could have picked it, which is that. So we just do that. So 4 factorial is my factorial divided by 4. So you get 6/28, which is 3/14. So there, we've proved it. B, now it says draw up a probability distribution table for x. Well, that means we have our x, and we have the probability that our x equals x. So the probability, you know, that the number of paperback books she chooses could be 0, well, it couldn't be 1, 2, 3, 4. Well, if you think about it, but you can't be 0, right? You can't. She always has to pick at least 2, because there's only 2 hardbacks, so she could pick a hardback, but then she's got 2 slots and only paperbacks. So this would be 0 and this would be 0. So I didn't actually need to put that in, but that's okay. And then we have this 3/14 for our 2. So let's figure out what it would be for 3. Well, that would be, you know, let's think of one case again, like we did before. You know, what if she picked it like this? Well, that's the probability of her picking 3 paperbacks followed by a hardback, which would be 6/8 times 5/7 times 4/6, and then times, she has 2 hardbacks and 5 books left. So that's the probability of one of those occurring, which we can again find out. 6 times 8 times 6 times 2 divided by 5. That's 1/7. But then we also have to consider, well, how many ways can this happen, which is the arrangement of this. How many ways can this be arranged? So that means the probability that x equals 3 is going to be equal to 1/7 multiplied by the number of ways this can be arranged, which is 4 factorial divided by, because there's 3 p's, 3 factorial. Over 3 factorial, which is just 4. So you get 4/7 here. And then for the fourth one, we know that the sum of all the probabilities has to equal 1. So if we go 1 minus 3/14 and then minus 4/7, well, we get 3/14 for the last one as well. Cool, and that's that one done. And now I ask you to find the variance of x. Well, you can just simply use an equation here for discrete random variables, which this is. So we can say the variance of x equals the sum of x squared p minus that squared. So it's going to be the sum of all these x's minus 3 squared, which is 9. Okay, so let's work this out. So that means the variance of x equals, well, the sum. Remember, these are the x values. So this is x. So these are the x values, 0, 1, 2, 3, 4. Well, these are obviously going to be 0, so this is 2 squared, which is 2 squared times the probability of when it's that she picks 2 paperbacks is 3/14 plus 3 squared times 4/7 plus 4 squared times what is it, 3/14 again, minus 9. So we put all that into our calculator. 3. So that's 12/14. 9 times 4 divided by 7 plus 12/14 plus 4 squared times 3/14. So, sorry, I messed up in my thing. Plus 3 squared plus 4 squared times 3/14 minus 9. So I get a variance of 3/7. Okay, so let's move to question 4, which says that a petrol station finds that the daily sales in litres are normally distributed with a mean of this and a standard deviation of this. Find how many days of the year the daily sales can be expected to exceed 3,900 litres. So in order to do that, we have to find the probability that on any random day, so we could call x being number of liters sold in a day. So we need to find the probability that the number of liters sold in a randomly selected day is greater than 3,900, and then we can find the expected value because we can just times that by 365. So we want to find the probability that x is greater than 3,900, and we know that these are normally distributed, so let's have a look at that, how it would look. We have a mean of 4,520, and we want to know what's the probability that it's greater than this. So this is this area. So what is this area? So this is the area. It's probably it's greater than 3,900 for this distribution. Well, we can find the corresponding z value for this, the corresponding normalized distribution, by plugging into this equation equals x, which is our 3,900, minus 4,520 over our standard deviation, which is 560, and that gives us 3,900 minus 4,520 divided by 560, which is minus 1.107. So the normalized distribution will look like this, which is equivalent to this. And it's 0, and this is minus 1.107 z for this. So, and that's the same area, but we can say, because this is symmetric, this is the same as saying this over 1.107, in this area. And the reason we do that is because we have a table which can calculate these. So that means, therefore, the probability that X, so on any randomly selected day, that the petrol sales in litres are greater than 3,900 is the same as saying the probability that Z is greater than negative 1.107, which is the same as saying the probability that Z is less than 1.107 due to the symmetry of the normal distribution. So all we have to do is find this, and this can be found on the graph, on the table in your formula sheet. So if we go to this table here, so we want 1.107, so 1.10, and then for 7 we add 14, so 1.107 would be 43 add 14 is 57, so it's 0.8657. So this is 0.8657. So therefore, the probability that X is greater than 3,900 equals 0.8657. So if that's the probability that if we select any random day, that the sales will be greater than 3,900, well, what's the expected value for 365 days? Well, that's just, we can call it the expected is just going to be 365 times by this probability. And if you put that in your calculator, 0.8657 times 365, you get 315.9. 315.9, but you can't have 0.9 of a day, so we could say it's the expected value is, let's say 316 days of the year. Cool. Let's continue. The daily sales of another petrol station are X litres, where X is normally distributed with a mean of M and a standard deviation of 560. It is given this. So let's draw out what's going on here. So we've got with a mean of M, and it will be on this side, so this is our 8,000, because it says where this is greater, so this is the probability that X is greater than 8,000, which equals 0.122. And I know it's on this side because this is 0.5, so for it to be greater it must be on the right side of the mean. So that means that this area is 1 minus 0.122, 1 minus 0.122, which is 0.878, 0.878. And that's going to be useful because we know this equation here of X minus the mean, which is M in this case. Because remember, we're trying to find M over the standard deviation. So if we can find the Z value corresponding to this X value here by looking on the graph. So we can look on the graph. So what we're trying to find is we want to find the Z value, which gives, so we don't know this, which gives an area of 0.878, because that's the Z value which equals this over the standard deviation of 560. So to find that Z value, we have to look on our table. So let's look on our table. So what was 0.878? I'm pretty sure 0.878. So we find it 0.877. So that plus 10, so it's 5. So it's 1.165. So this is 1.165. So that's saying that the Z value we're trying to find this for 0.878. The Z value is 1.165. That's what we needed. So now we can just solve this equation. So we get 1.165 times 560 equals 8,000 minus M. So 1.165 times 560, 8,000 minus answer is 7347.6. So your M is 7347.6. Cool. Now question C. Find the probability that daily sales at this petrol station exceed 8,000 litres on fewer than 2 of 6 randomly chosen days. So this is going to be binomial because you have a probability of success, and it wants to know how so our probability of success here is the probability that x is greater than 8,000. So on any randomly chosen day, what is the probability that x is greater than 8,000 is 0.122. So it wants to know that we choose 6 random days, so n is 6. What's the likelihood? So we can say, if you want to be really explicit here, you can say y is number of days petrol station exceeds 8,000 litres. Well, we want to find the probability of six of those days that 2 of them they exceed 8,000, fewer than 2. So this is y is less than 2. So we want the probability that y is less than 2, which is the probability that y equals 0 plus the probability that y equals 1. So this would be 0 times the probability of success, which is 0.122 to the 0 times the probability of failure, which is 1 minus that, 0.878. We already did that. 0.878 plus 61, 0.122 to the power of 6 to the 5. So therefore, put that in your calculator, you get 0.878 power of 5 times 0.122 times 6 plus is 0.840. Okay, so question 5 now. A fair die, 6-sided dice with the face marks 1, 2, 3 to 6 is rolled 90 times. Use an approximation to find the probability that a 3 is obtained fewer than 18 times. Well, we can see that this is going to be distributed binomially. So like if we have x, our random variable is, let's say, the number of throws which are a 3. Right, well, the probability of success in this case is the probability that on any roll we do throw a 3, which is just 1 over 6. That means the probability of failure is 5 over 6. So from this, then we can find, for 90 throws, we can find the mean and the variance of this binomial distribution. So the mean of x equals to the probability of success, which is 1 over 6, times the number of throws, which is 90, which equals 15. And then the variance of x equals NPQ, which is 1 over 6 times 5 over 6 times 90, which equals 12.5. And it wants us to find the probability that the number of throws in which we roll a 3 out of 90 throws is fewer than 18. And the reason that it wants us to find an approximation here, because if we wanted to find this through a binomial method, we'd have to do the probability of x equals 0 plus the probability of x equals 1 plus the probability of all this stuff plus the probability of x equals 17, and that would take ages for us to do. So instead of doing that, let's use a binomial approximation for this. and we can say, well, the mean of that we're making a normal approximation for this binomial distribution. So we can say that, to find the probability that x is greater than 18, well, we have a mean. We can say our mean of our normal distribution is 15 with a variance of 12.5, and it wants us to find where. So this would be the probability that x is less than 18. So if we find that, then we can find, and that's what we want to find, right? But the thing is, what you have to remember is, when making this approximation, we can make it better. So the probability that x equals 18, this is a good approximation, but if we actually zoom into here, so let's have a look at what's actually going on here. Like zooming into this, say this is the 18, and remember these are bars because they're like they're discrete values, and this would be 17 here, and this is our, the line here is our normal approximation. Well, when we're finding this area, well, we're finding all of this, right? Less than 18. But what we really want to find, because this is a binomial distribution, underneath this approximation, is we want to find, look, the probability that x equals 17 plus the probability that x equals 16, 15, 14, all the way to 0. So we actually want to find this. So a better approximation would be, because we're overshooting, we're adding this extra bit, and we don't want this. We want to have a good approximation. So a better approximation would be at 17.5. Hope that makes sense. So a better approximation, when we use this normal distribution approximation for the binomial distribution, would be this. And that simply equals to the probability that z is less than, well, 17.5 minus our mean, which is 15, over our standard deviation, which is the square root of 12.5, which gives us the probability of z being less than 17.5 minus 15 square root of 12. So 0.707. So then we can work that out. So we look on our table for what this area would be. So remember, we're finding this 0.707. We're finding this area, which is the same as finding this, the 17.5. So we go to our formula sheet. So 0.707. So this is 0.7601. So this equals 0.7601. So therefore the probability, let's write it all out, the probability that x is less than 18, it's the probability that x is less than 18 here, when it's a binomial distribution, is equal to 0.7061. So this is your answer. Boing. Justify this. Well, this is just simply because our NP is greater than 5, because this is 15, and our NPQ is greater than 5, and this is 12.5. That's how you know if it's a good idea to make a normal approximation. And then question C, on another occasion a die is thrown repeatedly until a 3 is obtained. Find the probability that obtaining a 3 requires fewer than 7 throws. Well, we know the probability of throwing a 3 is 1/6, so the probability of not throwing a 3 is 5/6. So it wants to know the probability of throwing a 3 requires fewer than 7 throws. That means that we want to find the probability of rolling a 3 in 6 rolls, because it says fewer than 7 rolls. So in 6 rolls, what's the probability of us obtaining a 3? So, you know, it could happen anywhere. And finding this would be difficult because you'd have to be like, okay, what's the chances of us getting it on the first roll and then nothing, or the second roll and then nothing, or the third roll and then nothing. Like, this would be difficult for you to do, but you can just simply say, well, this is the same as 1 minus the probability of, what's the probability of not rolling a 3 in 6 rolls? Well, this is just going to be 1 minus, what's the probability of not getting on the first roll? 5 over 6. What's the probability of not getting on the second roll? 5 over 6 times 5 over 6 times 5 over 6, 6 times. Right? I hope that makes sense. So then your answer will be equal to 5 over 6 to the power of 6. 1 minus answer is 0.665. So let's continue to question 6, which is clearly already I can see is going to be a permutations and combinations question. And they say that a group of 8 friends are traveling to the airport in 2 different taxis, P and Q, and each taxi can take 4 passengers. The 8 friends are divided themselves into 2 groups of 4, one group for taxi P and one group for taxi Q, where John and Sarah are traveling in the same taxi. So we have a taxi P, which has 1, 2, 3, 4 slots, and a taxi Q, which has 1, 2, 3, 4 slots. And it says find the number of ways in which this can be done. Well, we know that there's John and Sarah have to travel in the same taxi, so they can either travel into taxi P or they can travel into taxi Q. So let's say they both get into taxi P, just for example. Well, how many ways can this happen? Can the rest of them be chosen if they go into taxi P? Well, we have, 6 more people here. So two out of these 6 people can be picked into this. So how many ways can we do that? Well, we can pick out of the 6, we can put 6 different people in this first slot, and then we can put 5 different people in this second slot. So that's the number of ways that we can choose out of 6 into here. But we have to remember that, let's say, if they're arranged like this, well, this is the same as arranging them like this if we switch them over. There's no difference. It's the same way, and let's say if when we put J and S down, because that's just a given, we put them in this taxi. Let's say if we put J here and S and Sarah here. Well, when we selected these, we could still select 6 ways here and 5 ways there. Well, remember that if we just change these over, it's the same again. It's the same way. So once we've put John and Sarah into this taxi, there's 6 times 5 ways, but we have to consider that when we change these over, that it doesn't, we're not counting it as an extra way. So we need to divide this by 2 factorial, the number of ways in which we can arrange these people that we put in, these extra people that we put in. So we can say for this part is 6 times 5 over 2 factorial. And then the remaining, so we have then 4 remaining. Well, how many ways can we put them into here? Well, that's just 1. There's only 1 way we can do that. We have 4 people, and we put them in the taxi, Well, there's a 4 times, or you could say it's 4 different people in the first slot, 3 different people in the second slot, 2 different people, and then 1 different people, and you can multiply those together. But it doesn't matter if it's P1, P2, P3, P4. This is the same as P4, P2, P1, P3. So we need to divide by 4 factorial to get rid of all those ways. I hope that makes sense. There's only one way to do that. So that means that if we put John and Sarah into taxi P, so John and Sarah go into taxi P, and there's this, and then times 1, many ways, which equals 6 times 5 divided, so it's 15, right? But then you have to remember, they're saying that they can go into one taxi. So if they go into taxi Q, like if we put them into taxi Q instead, well, that's another 6 times 5 over 2 factorial times 1 ways. There's another 15 ways. So the total number of ways considering that John and Sarah have to go in the same taxi, is 15 plus 15. So total ways is equal to 30. Okay. Now B, again we have two taxis, taxis P and taxi Q, and it says that each taxi can take one passenger in the front and 3 passengers in the back. To see the arrow. Mark sits in the front of taxi P, so Mark's in this seat, and John and Sarah sit at the back. Man, John and Sarah really like each other. John and Sarah sit at the back of taxi P, so we can put John here and Sarah here. Okay, and then again we have our, the rest of the people chilling, right? And it says find the number of arrangements that are now possible for the 8 friends. Arrangements means that that P2 and P1 and P1 and P2 and P3, this is two different arrangements, 2 different permutations, but this is one single combination. So let's say for the first part, well, how many ways from 5 can we put, pick a person? Well, it's just 5. So we have 5 ways to put into this first taxi here. Or you can say it's 5 combination 1, right? Or just 5 ways. You can say 5. You can say 5 P1 if you want, if you want to be particular. But I'm just going to say 5 for now, and then I'll show you later. So there's 5, right? We can pick 5 different people. So let's say if we picked, I don't know, P1, and then we have J. Remember, it says they sit next to each other, so they're stuck together. So there's sort of, in a way, 2 slots here. So then if you want to see the number of arrangements of this, so we have 5 ways to pick this first thing, but then how many ways can we arrange this? Well, we can, switch these over, and we can say JS and P1, so that's times 2, so there's 2 ways that we can do that for every single way that we pick. And also, we can arrange the J and S back and forth. So you can switch this to SJ, and it would be a different arrangement. So that's times 2 again. Okay, so there's 5 ways we can pick this last seat, and then there's times 4 ways we can arrange it for each way that we pick. So for this first part, you could say mathematically, it's 5 P1 times 2 times 2, and then for the last one, well, that's just how many arrangements can we arrange for the 4 remaining people. We put them all in, like P1 or P2, P3, P4, P5, and then remember that's going to be different from P3, P2, P5, P4. So this is just plus times the number of ways that we can arrange this, which will be 4P4. So this is 5 times 4 factorial times 2 times 2 times 5. So it's 480 ways. So the answer is 480 ways. Okay? Cool. So that's that done. And then finally we have question 7, which we're given a bag A. So we can say A has, I like to always write this stuff out, 4, 5, and 8 balls, numbered. Bag B has 1, 3, 6, 8, 8. So it's 5 balls, 1, 3, 6, 8, 8. And bag C has 7, which is 2, 7, 8, 8, 8, 8, 9. And 1 ball is selected random from each bag, so they pick a ball random from each bag. Event X is when exactly 2 of the balls selected have the same number. Event Y is when the ball selected from bag A has the number 4. And it wants us to find the probability of X. Okay, so we just have to think of different ways that this can occur. So X could occur if we pick, so it says exactly 2. Exactly 2 of the selected balls have the same number. Well, the ways this could happen is, let's say it would be, so the probability of X would be, well, one of the ways this could happen is, let's say, if we pick a 2 from bag A, so you pick a 2, and then let's call it not a 2, and then a 2 from bag. So this is, the probability of, so this is picking a 2, so we pick a 2 from bag A. This is A, B, and C. This is our picks. And then we pick a not a 2 from bag B, and then we pick a 2 from bag C. So that's one of the ways it could happen. And then we got a plus, all the different ways it could happen. Well, 4s don't occur in each bag. So 4 only occurs in this one. 3 only occurs in B. 5 only occurs in A. 6 only occurs in B. So that means there's no possible way for any of those numbers to be selected twice. One from one bag and one from the other. And 8 is the only other number. So you could also do, you pick an 8 from bag A, and then you pick an 8 from bag B, and then you pick no 8 from bag C. Exactly 2. Right? That's exactly 2 of the numbers. Plus probability. You could pick a bag 8 from bag A, and then not an 8 from bag B, and then an 8 from bag C. And then finally you could also do no 8 from bag A, plus an 8 from bag C, and then an 8 from bag B as well. So those are the only possible ways in which you can get exactly 2 of the balls to have the same number. So all we have to do now is calculate these individually and sum them up. Well, this is going to equal to, what's the probability of picking a 2 from bag A? Well, remember there's 4 here, 5 here, and 7 here. So this is 1 over 4 times not a 2 from bag B is 100%. So it's 1. There's no way you couldn't pick a, there's no way you could not pick a 2, right? You're always going to not pick a 2. That's what I mean. Pick a 2 from bag C is 1 over 7. Plus this one. So it's going to be probability of picking an 8 is 1 over 4 times the probability of picking an 8 from here is 2 over 5 times the probability of picking no 8 from here is 1, 2, 3 over 7 plus this one, probability of picking an 8 is 1 over 4 times the probability of not picking an 8 from bag 2 is 3 over 5. Hope it's making sense what I'm doing here. And the probability of picking an 8 from bag C is 4 over 7. And then the last one is plus not picking an 8 from here is 3 over 4 from bag A. Picking an 8 is 2 over 5. And then finally picking an 8 from here again is 4 over 7. So what we do is we now calculate this. So the first one is going to be 1 over 28 plus, it's getting dark, I want to finish this before it gets dark, 6 divided by 4 divided by 5 divided by 7 is 3 over 70 plus, I'm going to take my time because it's easy to make a mistake here, especially because I'm in the dark, divided by 4 divided by 5 divided by 7 is 3 over 35. 3 over 35. And then this one will be times 4 is 6 over 35. Okay, and then we add them all together. Which is 47 over 140. So the probability of x equals 47 over 140. Okay, so that's that one done. And now find P of them both occurring, and hence determine whether or not they're independent. Okay, well, we know that the probability of x, to show that they're if they're independent or not, we have to show whether or not this equals this. So we know that P of X from the last one is 47 over 140, and P of Y equals, what's the probability that a ball selected from bag A, the ball selected from bag A has the number 4? Well, that's just 1 over 4. And then we want the probability that they both occur. Right, that means that the probability that you select a ball from bat 4 and then you get 2 of the same numbers. So the ways that can occur would be if you select a 4 and then an 8 and then an 8, right? 4 and then 8, 8, 4, and then there's no other way that they could both occur. So that equals 1 over 4 times probability of 8 from bag B is 2 over 5, and then probability of 8 from bag C is 4 over 7. So it's times 2 over 5 times 4 over 7. So that equals 1 times 2 times 4 divided by 5 divided by 4 divided by 7 is 2 over 35. So 2 over 35, and P of X times P of Y is 47 over 140 times 1 over 4, which equals 47, which obviously doesn't equal. So that obviously doesn't equal 2 over 35. So they are, so events X and Y are not independent. So they're independent of this equal, so they don't equal, so they're not independent. Question C. The probability that 2 balls are numbered 2, given that exactly 2 of the selected balls have the same number. Well, we know that this equation for event A given event B equals P of them both occurring divided by the probability of B. So that's our equation for, A given probability of A given B. And in this case, our A is, the probability that 2 balls are numbered 2. So we could say 2 balls are numbered 2, given that 2 of the selected balls have the same number, which is the same as this probability here, X. So it's event X, which equals the probability of, I'll just call this 2, the probability of them both occurring together divided by the probability of X. Well, the probability of them both occurring, if you think about it, well, the probability of 2 of the balls being numbered 2, well, this occurs here. So this is the same as this. If you pick a 2 from bag A, and then not a 2 from bag B, obviously, and then a 2 from bag C, well, this is going to be the only case where you pick 2 balls which are numbered 2, and you have exactly 2 of the balls that have the same number. So this is the same as the probability of 2 and 2, which we found above, which was 1 over 28. And this is 47, so this would be 1 over 28 of P of X, which was 47 over 140. And if you work that out, you get probability of 2 given X equals 1 divided by 28 divided by 47 over 140. And so the answer is 5 over 47. And that concludes this paper. Subscribe, like, and I'll see you later.